So Niels Bohr was a scientist. He was a Danish scientist, and he is the one scientist that is responsible for rings around the atom. So I'm drawing this picture up here on the left-hand side. So this would be a Bohr model. So basically what he said is protons and neutrons are in the center, and then electrons are on the outside. What he said is, I pictured electrons orbiting the nucleus much like planets orbiting the sun, but he was wrong. They're more like bees around a hive. So if I go over here to the right and I draw another picture of an atom, he pictured his data, came back and said, no, this is what our atom looks like. I'm not a good artist, but it's more like this. This is the one on the right is more like the Big Bang Theory atom, where there's electrons somewhere on these rings. Okay, so we know that's true. Bohr was the one who came up with energy levels. So energy levels are important because energy levels are the rings around the nucleus. So I'll get into that a little more later. So that's what Niels Bohr came up with. He was able to predict the energy of hydrogen where the electrons were. However, he was only able to do that for hydrogen and nothing else. So Bohr's model only existed for one element, not for any other elements. So next is where we really get into the quantum mechanical model, and its mathematical laws can identify the regions outside the nucleus where electrons are most likely to be found. Basically, this is where we get into really complicated math, and I'm not getting into that. I'm just going to summarize a lot of stuff for you. So a guy that's important is Werner Heisenberg. He's a German scientist, and one of his big discoveries was one cannot simultaneously determine both the position and the momentum of an electron. So it's like a car. If your car's moving, you know the speed of your car, but if it's moving, you can't figure out the position, or vice versa. If your car's stopped, okay, you're not going to know the speed, but you're going to know the position. So you can find out where the electron is, but not where it's going. So the Heisenberg uncertainty principle. Or you can find out where the electron is going, but not where it is. He just said you can't know both at the same time for an electron. So we do know electrons exist within energy levels. So this is an example over here, like a Bohr model. And he says electrons exist on these rings. They don't exist in between. They only exist on them. So generally symbolized by N. N means energy level. Energy level. And it says the probable distance of the electron from N is also the principal quantum number. So what you need to understand is the first energy level is closest to the nucleus. The second gets a little farther away. The third, the fourth, and the fifth. What you need to understand is that 2n, I'm going to cross that out, should be 2n squared. So how do you know how many electrons can exist within each energy level or each shell? Well, you're going to use this little equation down here, 2n2. So for example, if you have the first energy level, 1 squared, okay? So 1 squared is 1, and 1 times 2 is 2. So in the first energy level, there's 2 electrons that can exist. So if you do n is equal to 2, 2 squared is 4, 4 times 2 is 8. So in the second energy level, there's 8. If you do the third, 3 squared is 9, 9 times 2 is 18. So 18 electrons can fit in the third energy level. And then the fourth, 4 squared is 16, 16 times 2 is 32. So that's how many electrons can fit in each energy level. Well, get out your periodic tables. So I'm going to give you a minute to get out your periodic tables. I'm going to switch to a periodic table and show you where the energy levels are on your periodic table. So here's the periodic table. It doesn't look exactly like yours, but it's close enough. So on your periodic table, I want you to label the energy levels. Each row is an energy level. So this is your first, second, third, fourth, fifth, sixth, seventh. Down here, the bottom, these are part of 4 and 5. I will explain later, just trust me. So for example, remember how the first energy level, I only said 2 electrons can exist? This is the first energy level, 1, 2. The second energy level has 8. 1, 2, 3, 4, 5, 6, 7, 8. It has 8. The third energy level has 18. And you're like, well, Mrs. Buchanan, there's only 8 going across. This, where scandium starts, is part of the third energy level. I'll explain later, but the scandium to zinc, that's the third energy level. Yttrium to cadmium is the fourth energy level. We'll get into that a little bit later. But as long as you label the energy levels, you should be fine. So let's go back to the notes. If I go back to electrons. Okay. So electron orbitals, this is important. An orbital is a region of space within an energy level where there's a probability of finding an electron. And there's actually a 90% probability. So within the energy level, there's an orbital. Within those orbitals, you can find electrons. Orbitals are like orientations of where the electrons exist. There are 4 types of orbitals. There's S, P, D, and F. Okay? S has the lowest energy. F is the highest. So those are the 4 orbitals you need to know. S, P, D, and F. Now let's talk about their shapes. Orbitals have shapes. So the S orbital has a spherical shape. It's just the shape of a sphere. So only 2 electrons, I'm going to draw half arrows. That's how I call them electrons. But I have 2 half arrows here. So only 2 electrons can fit in the S orbital. Okay? So lowest energy, only 2 electrons can exist in there. And it's the shape of a sphere. You need to know what the shape is. P orbitals are, I call them dumbbells shaped. P orbitals have 3 orientations, and what I mean by that is an electron can fit along, one can fit, actually I'm going to change my color because it's purple. One can fit here, one can fit there, that's an electron, by the way. An electron can fit here, an electron can fit here. An electron can fit here, an electron can fit here. So a total of 6 electrons in the p orbital. There's 3 different orientations. There's the X, there's the Y, and Z. And the reason there's 3 orientations is because they're 3-dimensional. So we have a total of 6 electrons in the p orbital. After the p orbital, you have the d orbital. So again, only 2 electrons can fit within each orbital. So if only 2 electrons can fit within each orbital, then that means a total of 10 electrons can fit in the d orbital. We usually call the d orbital shapes donuts and dumbbells. Okay? So remember, these are the probable 90% probability of where you can find an electron. So this has 5 different orientations, and within each orientation, you have 10 electrons. Okay? A total of 10. The F orbital, now that's way crazier. And remember, these are all mathematically proven, they're theoretically, basically. With F orbital has 7 orientations, so 1, 2, 3, 4, 5, 6, and 7. They have 7 different orientations, and within each orientation, you have 2 electrons that can exist. So 2, 4, 6, 8, 10, 12, and 14. if you notice, when I draw my electrons, I draw half arrows. And it's really, there's a reason to this. And I always draw one up and one down. Electrons have spins. And when electrons spin, they have to be spinning in opposite directions. So when electrons spin, they spin in a clockwise and a counterclockwise fashion. So let me go back to the periodic table I was just at, and I'll show you where the s, p, and d orbitals are. So here are the energy levels. So let me show you where the orbitals are. Under the first two columns, this is the s orbital. And helium is part of the s orbital, so I'm going to put an s over there. So you can label this on your periodic table because this will help. This is the p orbital, everything over here under the right side. So everything that I'm boxing in is considered to be p. The yellow in the middle where transition metals are, that's considered to be d. And over here at the very bottom is f. So remember how I said the s orbital only holds 2 electrons? 1, 2. 1, 2, 1, 2, 1, 2. I'm going to keep going all through the s. 1, 2, 1, 2. The p, if you go back and look at your notes on p can hold 6 electrons. So we have 1, 2, 3, 4, 5, 6. The p can't go any higher than 6 electrons. The d is 1 through 10. Can't hold any more than 10. The f is 14, has 7 orientations, a total of 14 electrons can fit in an f orbital. So 1, 2 is the s, 1 through 6 is the p, 1 through 10 is the d, and the f is 1 through 14. So that's where the s, p, and d orbitals are. Within those orbitals, there's electrons. So if I go back, so let's look at this. So we have energy level. It's not going to let me. So I'll just write in here. Orbital type. We only can have s in the first energy. The number of orbitals is 1. The number of electrons is 2. And the number of electrons per energy level are... Hold on 1 minute. I'm trying to find something here. Hold on. I'm sorry. I'm just trying to get something together. So 1, and then so you can have a total of 2 electrons. In the second energy level, there's just s and p. There's 1 orbital in the s, and there's 3 in the p. Remember, only 2 electrons can fit in each orbital. So there's only 2 in the s, and then there's a total of 6 in the p. So there's a total of 8 electrons that fit in the second energy level. In the third energy level, there's s, p, and d. So there's 1 orbital in the s, there's 3 in the p, and there is 5 in the d. So 2, 6, and 10. So within each orbital, you have 2 electrons. So 5 times 2 is 10. So if you add all these up, 10 plus 6 plus 2 is 18 electrons. Okay? The next is the fourth energy level. You have S, P, D, and F. So in the first orbital, there's an S orbital, there's only 1. In the P, there's 3. In the D, there's 5. In the F, there's 7. So again, 2 electrons can fit in the S. A total of 6 electrons can fit in the P. A total of 10 electrons can fit in the D. And a total of 14 can fit in the F. So if you add all those up, 10 plus 6 is 16, plus 2 more is 18, and 18 and 14 is 32 electrons. So you have a total of 32 electrons can fit in the fourth energy level. So now is where I get into start talking about how to do electron configuration. So what is electron configuration? Electron configuration is basically the information that tells us where the electron exists within the element. So it's kind of like the electron's address. Just like where you live, you have a street address. You also have, you have a street number, you have a street name, you have a city and a state. So every electron has its own place. So I'm going to turn over here and it says the orbital filling table. So I've had you label on your periodic table 1 through 7, and I've also showed you where the S, the P, the D, and the F orbitals are. Okay, so we're just going to go practice this. So have your periodic table in front of you when you start doing this, because this is the only way to do it. So we're going to start with hydrogen and work our way across. So we always work left to right, and then we wrap back down, we wrap around. So if I want to write the electron configuration for hydrogen, to do that, you have to write down the energy level. So that's 1. You have to write down what orbital it is in. So we know hydrogen is in the s orbital. And then you have to write down the number of electrons it has, and it has 1. So hydrogen's electron configuration is 1s1. Keep going. We're going to go to helium now. We're working left to right. So helium is, write down the energy level it's in. It's in 1. Remember, I told you that helium is part of S, so it's S. And then how many electrons does helium have? It has 2, so 1s2. The number, the subscript up at the top or the superscript up at the top should always equal the total number of electrons the element should have. So if I look at the next one, the next element after hydrogen is, or after helium, is lithium. Okay? So to write the electron configuration of lithium, you have to include the row above it. So this entire row from hydrogen to helium is called 1s2. Okay? And the reason we have to include it is because we have to include those 2 electrons. If you look up lithium, you'll see that lithium has 3 electrons. So here's where 2 of them are. So then you have to look at what energy level is lithium in. It's in 2. What orbital is it in? It's in S. And now remember, I told you the s orbital can only hold 2. So we always start over after 2. So it'd be 2s1. Okay, after lithium, then we're going to look at beryllium. So I'm switching pages here just so you can look at the periodic table with me. So beryllium, I got to include the row above it. Beryllium is 1s2 because it's the row above. Then look at lithium. Then we're going to go left to right, then back down. Then we're going to have 2, and then S, and then we're going to start over at 1, 2s1. So if you count up here, that was my mistake. It should be 2s2 because beryllium is in the second spot. So if you count the number up at the top, it should total 4, and that's how many electrons beryllium has. So now let's look at boron. Boron switches because it goes into the p orbital, but you have to include the s orbitals in it. So starting back over at the top, we're going to say 1s2, then we have 2s2, and then boron, okay, we're still in the second energy level, but we have changed to the p orbital, so we're going to say 2p1, okay? So if you add up the numbers, that's 5 electrons. That's how many electrons boron has. So let's look at carbon. Start over at the top, 1s2, 2s2, that's 2s2, and then 2p2. And it keeps adding up. So if I was doing nitrogen, it would be 1s2, 2s2, 2p3. Oxygen would be 1s2, 2s2, 2p4. 1s2, 2s2, 2p5, and then neon is 2p6. So it keeps building up each time. And then you wrap back around. So if I wanted to do the electron configuration for sodium, I am going to say for sodium it is 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6. Remember, p can't be any higher than 6. And then 3, because that's what row sodium is in. 3, back to the s orbital, 1. So if I add them up, 6, 7, 8, 9. So 6, 7, 8, 9, 10, 11. So you have 11 electrons. Okay? I'm going to stop here because this is getting really long, and I'm going to do another one where we practice more of them and then finish talking about orbital diagrams and some rules with that. If you have any questions, email me or send me an email, message me through Google Classroom, and I'll be happy to answer the questions.